Okay, on problem 3.1.2 part D, we're supposed to find the probability that x is greater than 70. And we know that we have a mean of 72.6 and a standard deviation of 4.78. Now, in our class, we're using calculators, so that means we could actually skip a lot of the work on the normal distribution problems. So I'd actually just draw a normal distribution, and I say I want the probability that x is greater than 70. So I say, okay, well, here's x equals 70. Actually, if I look at the mean is 72.6. So you're kind of centered at about 72.6. So my x equals 70 would be over here. Not that that matters a lot, it just kind of helps me double check my work. And I want to find the area to the right. Now, this means all I truly have to do is I have to bring up my calculator, and I need to use the Normalcdf function. And Normalcdf function takes 4 values. You need to know your lower bound, your upper bound, your mean, and your standard deviation. Now, depending on which calculator you have, you might put these in different orders, but those are the 4 things you're going to need to do. So my lower bound, well, I want the probability starting at 70 and going up. Now, technically this should go to infinity, but I usually just say maybe like a 1 and type as many zeros until I get tired of doing it. So we'll put a really big number. My mean is 72.6 and my standard deviation is 4.78. Now, I don't have a calculator emulator anymore that I can do this on, but put it in and you should get that probability is about 70 or 0.7054. So that's the area to the right. Again, all I had to do was I just draw the diagram to realize, okay, I want x equals 70 and I want to shade to the right, so I'll do 70 is my lower and my upper bound is some really big number. And I put it straight into my calculator and I get my answer is 0.7054. Now, you might have noticed that the textbook does things differently. In this chapter, just completely ignore the textbook solutions. All you need to do is just look at it to see if you have the right final answer. And you just want your answer to be close. They're using a table, so their answer is going to be slightly different than yours. As long as it's fairly close, you know that you did it correctly. Actually, I just pulled this out of their book, so that might be slightly off too. That might be what they have instead of what you got out of your calculator, but it should be something close to that. Okay. As far as what the calculator or the textbook did do, this is the old-fashioned method. In the first step is you have to standardize, so you have to find a z-value. Z is always equal to your x minus your mean over your standard deviation. So 70 minus 72.6 over 4.78 gives me negative 0.54. And then they draw out this curve, and they say this is z equals negative 0.54. And they want to find the area to the right. Unfortunately, the normal table only gives areas to the left. So they look at the area to the left, which I have some notes down here, was 0.2946. And they say, hey, wait, I remember everything has to add up to 1. So they do 1 minus 0.2946, which gives them 0.7054. And they realize that was the final answer. Okay, so now as you read the textbook solutions, they're much more complicated than they need to be. You don't need to do things like, they said the probability that x is greater than 70 was like 1 minus the probability that z is less than negative 0.54, etc. So this is what the textbook was doing. They just kind of have to do theoretical notation. You don't need to worry about that. Draw your pictures. Okay. So first of all, come up here, use the calculator. If you are using the normal table because you don't have a calculator, because every semester I have 1 or 2 people that do, just draw the picture. Don't worry about the notation and everything that they say that they're doing. Just find your z-value, draw your picture.